In the fall of 2003, a farmer from Blount County brought me his 1998 Chevrolet Silverado 1500, 5-liter V8, 6-speed manual, the kind of truck that was built to work. His complaint was a ticking noise from the top end that he'd been hearing for about a month. He wanted to know if it was serious. I told him to back it into the bay, give me an hour, and I'd show him exactly what was going on. I pulled the valve covers in about 40 minutes. The rocker arms were worn, the push rods had some surface scoring, and one of the lifters was starting to collapse. Total parts bill for OEM replacements from the local parts house was around $220. Labor for the job, if I'd charged him for it, would have been about 3 hours at my rate at the time. But he was a neighbor, so I did it on a Saturday afternoon, fed him coffee, and taught his son how to adjust rocker arm clearance while we were at it. The truck ran quiet for another 6 years after that. I saw it at an auction in 2012 with 340,000 miles on the clock. Now fast forward to 2019, same basic job. A 2019 Silverado 1500 with the 5.3-liter Ecotec 3 V8. Same complaint, ticking from the top end. The owner, a man in his 40s from Knoxville, had already taken it to the dealership twice. The first time they told him it was normal valve tick. Nothing to worry about. The second time, 8 months later, when the check engine light came on, they told him he needed a new camshaft, lifters, and timing chain set. Quoted him $4,200. He wanted a second opinion before he authorized the work. I got the truck in my bay and spent 2 hours trying to isolate the noise. Here's what I ran into. The engine cover. It's one piece, molded plastic, with integrated sound deadening. It sits on top of the engine like a bathtub and is held down by 11 fasteners, several of which are torqued to specific specs and have plastic clip retainers that crack if you look at them wrong. To get to the valve covers, I had to disconnect the crankcase vent system, the mass airflow sensor wiring harness, the positive crankcase ventilation hose, and a fuel line bracket that sits right across the front of the cover. Then I had to lift the whole assembly off without bending or cracking it, because a replacement cover from GM runs about $840, non-returnable if you break it. I got the covers off. The ticking was coming from the number 7 cylinder bank, driver's side, and it was a collapsed lifter. Same basic problem as the 1998, just 31 years newer. But here's where it got expensive. On the 1998, I could have replaced that lifter by pulling the rocker arm and the push rod and dropping the new lifter in from the top. It would have taken me maybe 20 minutes. On the 2019, that lifter is part of an assembly. The 5.3-liter Ecotec 3 in these trucks uses active fuel management, which means the lifters are oil pressure operated and they're not individually serviceable. If one fails, the book answer from GM is a full AFM lifter kit replacement, camshaft inspection, and timing chain assessment. The dealer quoted $4,200 because they were being honest about the book time, not because they were trying to steal from him. The book time on that job is 11.5 hours. I told him to find a local machine shop that specialized in GM engines and get their opinion. He found one in Maryville. They told him the same thing the dealer did, but they gave him options. They could replace the individual lifter with an aftermarket unit designed for AFM engines, flush the AFM system, and monitor for code recurrence. Total cost with labor was $1,900. Better than $4,000, but it was still nearly $2,000 for a problem that would have cost $220 and 40 minutes of time on a truck built 21 years earlier. That right there is the whole story. Not a conspiracy, just engineering choices made to reduce manufacturing cost in ways that transfer the repair burden from the factory to the owner, and from independent mechanics to dealership service departments. The 1998 Silverado was built to be repaired by anyone with basic tools and a modicum of mechanical competence. The 2019 Silverado was built to be repaired by a technician with a GM-approved diagnostic laptop, GM-approved parts, and a service information subscription that costs $200 a year. If this is the kind of information you want, hit the subscribe button. I've been turning wrenches on pickup trucks since 1981. I have no sponsors, no affiliations, and no reason to tell you anything except what I've actually seen. Let's get into it. Now, the question I get more than any other, whether it's in the comments or in person at the shop, is what changed. People want to know specifically what happened because they remember their uncle's old truck or their grandfather's F-150 that just kept running, and they look at what's available now and something feels wrong. I'll tell you what changed. The integrated engine cover is one of the earliest and most telling examples. Go back to any full-size pickup from the 1990s, and the engine was open. You could see the valve covers, the intake manifold, the accessory drive system. If something was leaking, you could see it. If something was overheating, you'd smell it before it got catastrophic. The engine cover came in during the early 2000s, ostensibly for noise reduction. And yes, it reduced noise. But it also created a sealed chamber over the engine where small leaks could go undetected for months or years. Oil weeping from a valve cover gasket would collect in the cover, sit against the aluminum, and gradually eat through the cover's mounting surfaces. By the time the owner noticed the smell or the low oil warning, the cover itself was often ruined. A 1997 F-150 valve cover gasket cost $18 and took 45 minutes to replace with the truck on the ground. A 2018 F-150 with the 3.5-liter EcoBoost, replacing that same gasket requires removing the upper engine cover, the intake resonance chamber, multiple electrical connectors, the PCV system, and then fighting with the gasket that GM now bonds directly to the cover with a sealant that requires a specific torque sequence and a 24-hour cure time before you add oil. The gasket itself is $42. The labor, if you're paying someone, is 3 to 4 hours. Sound deadening and noise reduction are fine goals, but when the solution to making the engine bay quieter is to seal it so thoroughly that you can't see or smell what's going wrong until it's expensive, that's not progress. That's cost shifting. Let me talk about four-wheel drive because this one really gets me. The mechanical shift-on-the-fly system that was standard on virtually every full-size pickup through the early 2000s was not complicated. You had a front axle with a manually engaged, disengaged differential, a vacuum-operated hub lock system on the front wheels, and a transfer case with a mechanical shift lever or knob that physically moved the gear set between two-wheel drive, four-wheel drive high, and four-wheel drive low. It was robust. It was repairable. If the vacuum hub actuator failed, you could bypass it with a manually operated hub conversion. If the transfer case shift motor went out, you could replace it with a unit that cost $120 and took an hour to swap. If you sheared a tooth on the input gear, you could see it, diagnose it, and replace just that gear. The push-button electronic four-wheel drive system that's now standard on most half-ton pickups is a different animal entirely. When you press that button on the dash, you're not mechanically engaging anything. You're sending an electronic signal to the transfer case control module, which actuates an electric motor that moves a shift fork, which slides a clutch pack to engage the front differential. The front axle is always partially engaged. The system uses a combination of clutch packs, electronic sensors, and active traction management algorithms to determine how much torque to send to the front wheels at any given moment. When it works fine. When it doesn't work, you need a diagnostic scanner capable of communicating with the transfer case module, a wiring diagram to check for power and ground at the encoder motor, and in many cases a replacement transfer case encoder motor that costs between $300 and $600 plus programming. I've had 3 trucks come through the shop in the last 2 years with electronic four-wheel drive failures that the owners were told required complete transfer case replacement at a cost between $4,000 and $7,000. In 2 of those 3 cases, the actual problem was a failed encoder motor harness connector that had corroded internally. The connector was $47. But you can't see that connector without dropping the transfer case, and the dealer wasn't about to spend 3 hours diagnosing a $47 part. They quoted a new transfer case. If you're buying a used truck and you live somewhere where winter weather makes four-wheel drive necessary, the presence of shift-on-the-fly versus push-button electronic should be a deciding factor. The mechanical systems from the 1990s and early 2000s were not perfect, but they were honest. You could feel them engage. You could hear them. When they broke, you knew why. Oil pans used to be stamped steel. When you hit a rock or a parking curb, the oil pan would bend. You'd jack up the truck, hammer the dent out from the inside with a ball-peen hammer, clean the mounting surface, slap a new gasket on, and be under the truck for maybe an hour. Stamped steel pans were not elegant, but they were repairable and they were cheap. A replacement stamped steel oil pan for a 1999 Chevrolet Silverado was about $65. Aluminum and composite oil pans started showing up around 2008, largely driven by emissions regulations and weight reduction targets. The theory was that lighter components improved fuel economy, which helped manufacturers meet CAFE standards. The reality is that aluminum pans crack under thermal stress, and composite pans crack under any impact at all. A cracked oil pan on a 2015 or newer full-size pickup is not a dent you hammer out. It's a replacement part that costs between $300 and $800 depending on the model, requires the use of the manufacturer-specific oil pan sealant in addition to the gasket, and often requires the subframe to be dropped or loosened to get the new pan seated properly. A 2016 Ford F-150 with the 2.7-liter EcoBoost I worked on last year had a cracked composite oil pan from a highway debris strike. The truck had 48,000 miles on it. The owner had to replace the entire oil pan assembly, and the dealership charged him $940 in labor because the job required the front cradle to be loosened and repositioned to access the rear mounting bolts. The part was $312. Labor was $628. That's the math of modern truck ownership. The parts are sometimes cheaper, but the labor to access and install them has tripled or quadrupled because the vehicle was not designed with serviceability in mind. Variable valve timing systems are one of those features that gets marketed as a performance and efficiency benefit, and it is, on paper. VVT allows the engine's computer to adjust camshaft timing on the fly for optimal power and fuel economy across the entire RPM range. What manufacturers don't tell you is that these systems are critically dependent on clean oil at the correct viscosity and change interval. The VVT solenoid uses oil pressure to actuate phasers that advance or retard the camshaft. If the oil gets dirty, sludges up, or is used past its change interval, the solenoid ports clog and the phaser fails to actuate properly. When that happens, you get camshaft timing errors, check engine lights, and in severe cases, catastrophic valve-to-piston contact. The maintenance interval that preserves VVT systems is roughly half what manufacturers recommend for overall engine oil service. Most manufacturers recommend oil changes every 7,500 miles for synthetic blend or full synthetic. Most VVT systems in GM's AFM range and Ford's EcoBoost lineup will benefit from changes every 3,750 to 5,000 miles, especially if the truck is used for towing or in extreme temperatures. The manufacturer has no financial incentive to tell you this. Every premature engine failure that gets attributed to lack of maintenance is a potential warranty claim that they can deny, followed by a very profitable new engine or new vehicle for the customer who thought they were following the recommended service schedule. I've pulled engines from 2011 to 2016 model year trucks with fewer than 100,000 miles where the failure mode was directly attributable to VVT system degradation from deferred oil service. In every case, the owner had the oil changed at the manufacturer recommended interval, had the service records to prove it, and was told by the dealership that this was just bad luck or a manufacturing defect. Some of those claims were honored under warranty. Most were not. The ones that weren't ended up as trade-ins at a significant loss to the owner and a significant profit to whoever bought them at auction and put them back on the road. What's the most expensive repair you've had on a newer truck that you couldn't do yourself? I want to know. Drop it in the comments and tell me what the truck was and what the dealer quoted you. I'll try to get back to as many of those as I can. Let's talk about windshields now because this one catches a lot of people off guard. Lane keep assist, forward collision warning, adaptive cruise control, and automatic emergency braking all rely on cameras and sensors that are mounted behind the windshield. The forward-facing camera for lane departure warning and automatic emergency braking is typically mounted in a small housing bracket attached to the interior side of the windshield glass, usually just behind the rear-view mirror mount. When you crack your windshield and need a replacement, that camera and its mounting bracket have to be removed before the glass is taken out and reinstalled on the new glass before you leave the shop. The problem is calibration. After any windshield replacement on a vehicle equipped with these systems, The camera and radar sensors must be recalibrated using manufacturer-specific equipment. This is not optional. If the camera is not recalibrated, lane keep assist may not function, forward collision warnings may fire incorrectly or not at all, and adaptive cruise control may behave erratically. On most 2018 and newer full-size pickups, this recalibration requires the dealer or an independent shop with the correct diagnostic hardware to perform a target-based calibration using a specific pattern board positioned at a specific distance from the vehicle. This process takes between 2 and 4 hours and costs between $200 and $500, depending on the manufacturer and the local market. Most independent glass shops will not do this calibration. They will install the glass, reassemble the trim, and tell you to take it to the dealer for calibration. The dealer will then charge you the calibration fee, which is on top of the windshield replacement, which on a 2019 or newer full-size pickup with rain-sensing wipers and a heads-up display can run between $800 and $2,500 for the glass alone. I've seen owners get quotes of $3,400 for a cracked windshield on a 2021 F-150 because of the camera and sensor package complexity. If you own one of these trucks, get a glass repair instead of a full replacement whenever the damage is small enough. Most windshield repair shops can fix a rock chip or small crack for under $100 and preserve the original calibration. Once the glass is replaced, you're committed to the calibration cost. This brings me to the labor rate conversation that I think every truck owner needs to have before they buy a newer model. This is why the push toward increasingly complex electronics and proprietary software in pickup trucks is not a neutral technical decision. It's a business decision that has the effect of concentrating repair capability in dealership service departments and excluding independent shops and home mechanics from the market. Every repair that requires dealer-only software is a repair that you're guaranteed to pay dealer rates for, no matter how simple the underlying problem is. If you're in the market for a used pickup truck and your goal is to keep it for a long time, to maintain it yourself, and to minimize your total cost of ownership, there are specific things you should look for and specific things you should avoid. Look for trucks with manual shift on the fly four-wheel drive. These are increasingly rare in newer models, but they're still available in the used market, especially in model years from 2008 to 2016. A 2011 F-150 with the manual transfer case shift is a fundamentally different ownership proposition than a 2019 F-150 with the push-button electronic system. The older system will require more periodic maintenance on the front axle and transfer case, but when it fails, you'll know exactly what's wrong and you'll be able to fix it without specialized equipment. Look for trucks with steel oil pans. This means mostly pre-2008 model years for most manufacturers. Some manufacturers moved to aluminum pans earlier, but the trucks that still came with stamped steel oil pans into the late 2000s will serve you better over the long haul. When you hit a rock, you'll bend the pan. You can fix a bent pan, you cannot fix a cracked composite pan. Look for trucks with iron or aluminum intake manifolds rather than plastic. This is a harder search because the plastic manifold became standard across most manufacturers by the mid-2000s, but there are still exceptions. The GM Vortec 8.1-liter big block used an aluminum intake manifold that was virtually indestructible. Ford's 6.8-liter V10 used an aluminum manifold. If you want a V8 and you want it to be serviceable, these are options worth considering. Look for trucks without adaptive cruise control, lane keep assist, and forward collision warning systems. These features add significant cost and complexity to the vehicle and create expensive repair scenarios when the windshield needs replacement. They also add electronic failure points that can only be diagnosed and repaired at a dealership. A 2013 or 2014 model year truck without these options is a much better ownership proposition than a comparable 2019 with them. Look for trucks with conventional hydraulic parking brakes. The cable-actuated hand lever or foot pedal system is not glamorous. It's not new, but when it fails, you can see why, you can fix it yourself, and you can adjust it without a computer. That simplicity is worth more than most people realize until they're stuck with a $1,000 electronic parking brake repair on a truck with 80,000 miles. Look for trucks with removable engine covers if possible. This sounds minor, but the ability to visually inspect your engine bay without disassembly is significant. Early oil leaks, coolant seepage, belt condition, hose condition, All of these things are visible at a glance on an open engine bay. On a truck with a fully integrated engine cover, these problems hide until they become expensive ones. The trucks I would target if I were buying today, based on what I've seen come through this shop over the last decade, are 2007 to 2012 model year full-size pickups from Ford, GM, or Ram, with the specific configurations I've described. The 2007 to 2012 model years were a sweet spot where the trucks still had significant mechanical content, were not yet fully integrated with the proprietary electronic diagnostic ecosystems that came later, and had accumulated enough miles that their failure modes were well documented and their repair solutions were proven. A 2009 Ford F-150 with the 5.4-liter 3-valve Triton is not a perfect engine. It has specific camshaft phaser and variable valve timing solenoid issues that are well documented and well understood. But those problems are known, the parts are inexpensive, and the repair procedure is documented in detail. A mechanic who knows what he's doing can address these issues for a total cost of under $800 in most cases. Compare that to a 2019 F-150 with the 3.5-liter EcoBoost, which has direct injection carbon buildup issues, turbo bore charge boost solenoid failures, and water pump housings that crack. Those repairs require engine disassembly that often exceeds $3,000 in labor alone. The trucks that represent the best value in the used market are not the newest. They're the ones that were built before the industry decided that repairability was an acceptable trade-off for manufacturing cost and dealership service revenue. I know that not everyone can buy a 2009 truck. I know that some people need the features, the safety equipment, or the financing terms that only come with a newer model. But I want you to go into that purchase with your eyes open. Know what you're buying. Know what it will cost to repair when something goes wrong, and know whether you'll be able to fix it yourself or whether you'll be dependent on a dealership service department that charges $200 an hour to diagnose problems that a man with a timing light and a set of wrenches could have found in 20 minutes. The truck you can actually fix is becoming harder to find, but it's not gone yet. You just have to know where to look. If you learned something today, hit subscribe. If you've got a story about a repair that cost more than you expected on a newer truck, I want to hear it. Drop it in the comments. I'll be reading.